Now, ternary ionic compounds, ternary means three, and so it means three parts in name. And what you need to pay attention to this one is that the metals in these compounds form more than one type of positive charge. So they have variable charges. And the charge on the metal ion must be specified using Roman numerals. And transition metal cations are usually the ones that require a Roman numeral. So the name will look like this. You have a cation or a metal, open parentheses, that's the charge of the metal. In Roman numerals, like you use, 1, 2, 3, 4. Generally, these are the ones. And of course, you end with the anion or the non-metal. So I'd like to use an analogy for this. An analogy is like in the classroom. Imagine we're in the classroom or let's say this teacher is in the classroom and we have two students with the same name. We have two students with the same name. So let's say in that classroom, we have two Nancys. Now, if the teacher calls on let's say one specific Nancy, both of the Nancys are going to raise their hands, right? Say, yes, Miss or Mr. or whoever. So the teacher then would have to say, okay, you know what? I need to cause less confusion and just call on the one that I need to answer. Well, the only thing that the teacher can do afterward is either use the last name, or maybe the initial. So let's say the first Nancy has an middle initial of M, or the last name, the first initial of the last name, M. And let's say the other Nancy has an initial of S. So notice here, that's what happens with transition metals is they have different charges. So like iron, for example, can be +2 and iron can be +3. So we have to call this iron an iron, open the parentheses, Roman numeral 2. And the second one is iron, open parentheses, Roman numeral 3. You can see the analogy between these two. And that is why we use this system. Now, we did not have to do this with sodium, for example, because if you look at your sheet, the ion sheet, there's only one sodium, and that sodium is simply a +1. So we call it a sodium. We don't call it sodium 1 because there's only one. It's like there's a student in the classroom. That student is one student, let's say, is Michael. The teacher does not have to call Michael by, say, Michael, and then followed by the last name or the first initial, because there's only one Michael. That's the idea here. So let's get back to our problem. We have these two. Now, the best way to do these problems is whenever you suspect there's multiple ones, is to really list the ions. So if I have FeCl2, that means I have 2 Cls. I have FeCl3, that means I have 3 Cls. And then start with the anion. So start with the anion. Look, we're doing this as a scaffolding. We're beginning so we understand, and then of course you can use your own shortcuts. But let's go find the charge on Cl. So if you find the charge on Cl, you'll find that it's a -1. It's a -1. So then you ask yourself this question. Why would I need two Cl's here? If this is a -2, right? They add up to a -2. Then this must be what in order for the charges to cancel out? You're right, a +2. So a +2 and a -2, they cancel out. So that's how you extract, in a sense, this charge, all right, of the metal. Now, this, as we said before, we have two types of iron, so we have to be careful. Once we find that it's iron +2, we have to call it by this name, iron 2. And of course, we know the name of this is chloride. Now, if we do the next one, look at it. You have 3. You have one more than the top. Then what can you say about the charge of Fe? It's a +3. So therefore, again, this adds up to a -3. So this is iron now. Without even looking at it, if this is iron 2, then this would be iron 3 chloride. So that is how you would name these. So here's an iron 3. Now let us move to, before we move on, iron 2 is sometimes referred to as ferrous, and iron 3 is ferric chloride. Once again, there are people who take, some patients who need to take iron for anemia. So they take pills of iron tablets here, of course, and it's usually the ferric chloride or the oxide. So let's go to the next one. So you can again tell really the charge without looking it up by looking at the parentheses. So if it says iron Roman numeral 3, right away it says +3. If you are not sure, you can look it up. Here it is, iron 3. And then while we're there, we can look up oxide, which we did before. It's O-2. So then the question is, what do we do? Well, again, if they're different, the charges, you cross them. That's a quick way of doing it. But I will show you the longer method on this one as well. So you have Fe, the 2 came after that, so it's a 2, and then O, the 3 came after the O. This is rust, by the way, that coat on iron when it rusts. So there you go. That's the idea here. Now, how would you do this the longer way? Because it has to make sense. Well, you say O-2 and O-2 and then Fe +3. Well, you look at it from a quick math, simple arithmetic, is what is the least common multiple between 3 and 2? It's 6, right? That's the least common multiple. So you say, okay, if it's 6, then I need to make this side a +6, and I need to make this side a -6. Well, and then you just work out the math here. If I have a +3, I need how many more to get to a 6? I need another one. And here, if I have a -2, and I need to get to a -6, or just, from 2 to 6, if you want to think about it that way, and then add the negative, then you need 2 more. And isn't that Fe2, 2 of them, and 3 oxygens? The next one, copper 1 phosphide. Okay, so let's go find copper 1. Or if you know the symbol, you'll know what it is. It's actually Cu plus 1. Here it is, copper 1. And since we're here, let's check phosphide. Phosphide is right there. Fp minus 3, or -3. Now again, if they're different, you cross them. So you get Cu 3p. Once again, you should probably try to do the longer method so you understand it. Very well. Here we have chromium, and then we have a nitrite after it. So how do we name this? Well, you want to get the charge of chromium. So you say chromium, there's only one. And there are 2, if you look at this, there are 2 nitrite ions. So these are 2 of them. That's what it means. Okay. Now nitrite is right here. It's a -1 charge. Now, if we have 2 minus, so we have a -1 and a -1, that's a -2. Again, go back to what we did before. What would be the charge of this if this is a -2? Or why did we need 2 of them? Because this must be a +2. Correct. So therefore, when we name this, we go find what Cr +2. That's going to be really chromium 2, but we can go and look it up. Nitrite, because that's the name of these. Here's chromium 2. Chromium 2. Okay, Mn and CO3. Now, a common mistake that I've seen students commit is that they start with the polyatomics as they start breaking this into ions. You cannot do that. Remember, once you identify your metal, then what comes after it is a nonmetal. So all of these are nonmetals, and you can verify them. You have C and O, those are on the right side of the periodic table. So just separate your metal, that's manganese, from the nonmetal, and then look up the charges. So here we go. So we go and find CO3. It's right here. Has a -2 charge, and it's called carbonate. So if there's only one carbonate, then what would be the charge of manganese? Because it canceled out. There's no parentheses, nothing. There's only one carbonate. It would be a +2. So therefore, this would be called manganese. This is not magnesium. This is different. Manganese 2, Roman numeral 2, carbonate. So here's manganese 2. So continue. We'll do the last one here. So be aware, be careful. This is CO, not carbon oxygen. This is cobalt. So CO is the element cobalt. It's right here on the periodic table. So be careful. Sometimes it's confused. So we have cobalt, and we have carbonate as well here. So we have CO2 parentheses 3. Now, there's a quick way of doing this as well. You can use the quick way. You can do what we call the uncrossing of the charge. You take that 2 right here, put it in the upper right-hand corner of the CO3, and you take that 3, you place it again in the upper right-hand corner of CO, of cobalt. So it would become like this, CO plus 3, and then CO3 minus 2. Now, even if you don't like this, you can say, okay, what am I supposed to do? Well, you list them. You have CO and CO. You have 2 of them. And you have 3 carbonates. Now, remember what I said is you must go to the ion first and find its charge. Now, we did carbonate before. It was CO3 minus 2. Now, if you have 3 of them, each with a minus 2, each with a minus 2, then the charge on cobalt, the only charge possible on cobalt must be a plus 3, Why? Because again, these would add up to plus 6, and these would add up, I'm talking about the charges, the negative 2, the negative 2, the negative 2 would add up to a negative 6. So again, that's the approach that you want to use. So what is CO3? That's cobalt 3 carbonate. Very well. Do enough of these because you do need the extra practice.